My name is Colin Baird, and I'm a senior solution architect at MongoDB. And in this video, we're going to be covering multi-region replication, architecture, and considerations. So, as I mentioned, we are going to cover a little bit about replica sets, what the failover process looks like, priority votes, and tunable consistency. And then finally, we'll wrap up by actually covering a few examples of common multi-region architectures, as well as a walkthrough in our Atlas data platform. So, in MongoDB, we achieve high availability through the use of replication. And now in this example, we can see that we have a healthy 3-node replica set. Now, by healthy, what I mean is that each of the nodes sends a heartbeat to one another every 2 seconds. So, if any node were to fail to respond to a heartbeat for more than 10 seconds, then the other active members of the replica set deem that member to be unhealthy or offline. So now, if this were to happen to one of our secondaries, then no election process would take place. We would still have a majority of nodes, and everything would continue to function normally. Now, in this example, though, we can see that our primary is the one who stopped responding to the heartbeat. So this triggers an election process between the remaining 2 active members of the replica set. And so now we can see that once that election process has taken place, one of our former secondaries has now become a primary. And this process, failover an election, typically takes place in a matter of a couple seconds. And with retriable reads and retriable writes enabled, from the perspective of your application or your end users, there should be no visible impact. So now, when the offline member starts to come back online and starts to reinitiate a heartbeat with the other active members, it will enter recovery mode. And during recovery mode, it's basically catching up and resyncing any data that it missed while it was offline. And then finally, once the node comes back online and is fully in sync, it'll step back as another active member of the node, and this time it will assume the role of secondary. Now, this all depends on the priority level assigned. So we can see in this example, our newly elected primary remains primary. There's no other election that takes place. But if you have a multi-region cluster, then you might want to consider that, hey, if that former primary that went down was co-located in the same region as our app servers, once it comes back online, we would really prefer another failover to take place and for it to reassume the role as primary. And so with that, we can achieve that through assigning different priority levels to our nodes. So what do we mean by priority? Priority really just defines how likely a replica member is to be elected as a primary in the event of an election. So the default priority is 1 for primaries and secondaries, but can really be tuned as a decimal value between 0 and 1,000. So the higher the priority, then obviously the higher the likelihood that that member will become the primary. So now this brings us to the concept of votes. Votes really refer to how many votes each replica member can cast in the event that an election takes place, voting for which member becomes the new primary. So now with a replica set, we can have up to a maximum of 50 replica members, but it's important to keep in mind that we can only ever have a maximum of 7 voting members. So this brings us to the concept of majority. So now, in order for MongoDB or a MongoDB replica set to be considered healthy and writable, the replica set must maintain a majority of active members. So for example, in a 3-node replica set, we need 2 of 3 to be active, which gives us a fault tolerance of 1. Now in a 5-node replica set, we would need the majority, which would be 3, to remain active, which gives us a fault tolerance of 2. So 2 replica members can go down, etc. Majority also pertains to write concerns, where since version 5.0, MongoDB's default write concern is majority. So now if we have a 5-node replica set, we need write acknowledgement from 3 of the 5. We need to ensure that we maintain a majority for our writes to commit. Now, The last thing I'll mention here on this slide is that it is always recommended to deploy an odd number of replica members, as an even number of replica members can risk split brain in the event of a partition between nodes. So let's say, for example, we have an even number, a 4-node replica set. We have 2 in one region, 2 in another. There's a network partition between the two, but now each side believes that they have majority and tries to accept rights, and this is when you have data inconsistencies, etc. So look up the term split brain if you're not familiar with it and how it relates to architectures in MongoDB. So now this brings us to write concerns. In the last slide, I mentioned write concerns, which really can simply be defined as the number of replica members that we want write acknowledgement confirmations from before we consider the operation to be committed. So as of 5.0, with the write concern of majority, in a 3-node replica set, 2 of the 3 need to confirm write before the operation is committed. And similar to priority and votes, write concerns are tunable and really give you the ability to define the levels of consistency that you require for your database. So here we have a visualization of what this looks like. We can see that we have our MongoDB driver that will relay an operation, in this case a write from the application to our cluster. We can see that obviously the first stop is the primary. It commits the operation to the primary, but it doesn't acknowledge the operation is committed to the driver just yet. It still needs one other confirmation. So we need to wait for the replication to one of our secondaries to confirm before we actually send acknowledgement back to the driver, and then we can move on to the next operation. So now here with this said, an important consideration will be the distribution of your replica members. So, in a single region or even in a single availability zone, your latencies for replication will be very, very low if your replica members are co-located. But as you expand across availability zones, expand across regions, that network route becomes longer, then you need to consider what your replication lag looks like, because generally speaking, the higher that you increment your write concern, the longer your operation latencies will become. So now we're going to get into actual multi-region architectures and considerations. So the first thing that we should start with when we're approaching this type of scenario is really understanding, what it is we are trying to achieve, right? So start with why. What are we solving for? What pains do we believe that multi-region will address? And to wit, is multi-region even necessary? Can we achieve what we are aiming for by the use of distributing across multiple availability zones, partial region fault tolerance? Or what about an advanced disaster recovery policy? Would that be enough to get us to where we need to be? If we have a very low RTO based on, how we've distributed our snapshots and how we're tailing the op log, etc. And then, what are we optimizing for? So this is going to be a really important one to evaluate. Are we optimizing for minimal latency? Are we optimizing for maximum consistency or availability, etc.? So really kind of figuring out what your top 2 or 3 priorities and stack ranking these is going to be really important in determining the best course of action for you. And then finally, once we've decided on a course of action, how are we going to define and measure success? What are the metrics, the KPIs that we're going to be measuring for, hey, yes, this has been a successful endeavor. And so I have a couple of good reasons and not so good reasons. I'm not going to go through all of them, but obviously on the good reason side, one of the most obvious is stringent uptime SLAs. You have guarantees to your customers or end users for availability, and in order to meet those, you feel or have determined that you need full region outage fault tolerance. Another one is going to be compliance, around data locality. So in this event, we would have potentially a sharded multi-region cluster where, to conform to GDPR, one of our shards resides in EU and all of our EU users only interact with data on that shard. and then we have another shard in another region, etc. And then finally, optimizing for read latencies is another potential region for distributing across multiple regions. Not so good reasons, active active. That's a different conversation. You might be most likely looking at sharding versus a standard multi-region replica set. Since in that a standard replica set will only ever have one primary or one active member, and the rest are replicas. So anyway, let's get into our first architecture. Now, this one is not technically a multi-region configuration, but I still wanted to touch on it because it is best practice if you are deploying in a single region, and that is multiple availability zones. So you're deploying in US East 1, you still will want to deploy across availability zones to guarantee, at the very least, partial region outage fault tolerance. So here we can see in this example, we have 3 availability zones, and again, what this gives us really is a fault tolerance of 1 because we still need a majority. So one of these data centers or availability zones goes down, one of the nodes, we're still available, but it doesn't protect us in the event of a full region outage in this region that we're located in. So to do that, the first architecture we'll talk about is going to be 3 nodes distributed across 3 regions. So again, we still have a fault tolerance of 1, meaning 1 full region, and one node can go down, and we're still highly available. We still have a majority of 2 of the 3 nodes. So now, an important thing to call out here is going to be why 3 regions? Why not just 2 regions for the 3 nodes, right? So we have 2 nodes in region 1 and then 1 node in region 3. Now, the reason you don't want to do that is because really it's kind of a half measure. So there's a 50-50 chance that you're protected against a full region outage, not actual guarantees. So with that said, if we have 1 node in region 2 and we lose region 2, then okay, great, we still have 2 nodes left in region 1, we have our majority. But if we lose region 1 where our 2 nodes are located, then we only have 1 active node left, which then enters read-only mode. So, that's why if you want to stick with, the minimum number of recommended replica members, which is 3, then the recommendation would be to deploy across 3 regions, 1 node per region. So now this architecture here is 3 nodes, or I'm sorry, 3 regions and 5 nodes. And now this is probably the most common and the most optimal for general use cases that I've seen that have multi-region requirements. And there's a couple reasons for that. 5 is really kind of the sweet spot where you can guarantee different things like availability, consistency, making maintenance easier, having multiple nodes in a single region. So a variety of factors. But again, here, we have, in this case, we have a fault tolerance of 2 in terms of nodes, and a fault tolerance of 1 in terms of regions. And so, if we were to lose region 3, we would still have a majority of our nodes. If we were to lose region 2, we would still have a majority of our nodes, and vice versa. So now, again, similar to the last example, consideration here is, why a 2-2-1 architecture versus maybe a 3-2 or a 1-1-3. Now, in the event of a 3-2, the exact same scenario applies, where, if we lose our region with 3 nodes and we only have 2 regions, then, we're no longer highly available. We're not protected. And then, a 1-1-3, similar logic, right? We lose the 3 node region. We only have 2 nodes left. It's not a majority. So, you can kind of continue to see how you iterate this on if you're incrementing through 7 nodes, etc. But really, these are some of the main factors that apply for multi-region architectures. Now, with that said, I'll wrap up here before moving to Atlas with some considerations. Now, most of what we just discussed applies to multi-cloud and sharded clusters. So, maybe you have requirements beyond just region outage tolerance. You also want cloud outage tolerance, right? If AWS or GCP goes down, you want to have a fail-safe and ensure that you're deploying into those other providers. or failing over rather. And similar with sharded clusters. So again, I really wanted to emphasize on what are we optimizing for, ensure that you have your kind of priorities mapped out before you undergo this, rather than saying like, hey, this is just a directive that we have. Really understand the core drivers. And this kind of ties into the third one, which I actually see surprisingly often, is your application multi-region fault tolerant, right? So it's not going to do you any good to have a highly robust data set, multi-region, multi-cloud fault tolerant, when your application is just in one region, right? So if your application goes down, I mean, great, you can access your data, I guess, but you're going to have bigger problems. So evaluate that side as well. And then other things that we discussed, what is our majority cutoff? A majority of data bearing nodes. Are we architected to protect for split brain? What levels of region tolerance do we have, full or partial? Now, the great thing about Atlas, our data platform, is we have guardrails in place to ensure that you don't really have to think about these things. You can deploy without having to worry about misconfiguring. But finally, the last couple of considerations: read and write latencies. As you expand and distribute across more regions, you're expanding the gap between that the data has to travel between data center A, data center B, or region 1, region 2, etc. Then you are going to want to measure replication lag, RPOs, things like that, and ensure that you're still conforming to your requirements. Finally, these are going to affect network transfer costs. This is especially applicable in terms of sharded clusters and multi-cloud clusters. So the more data that you're propagating to the more nodes across longer network paths are going to incur higher costs. And then finally, security, right? So you probably have VPCs, VNets, things like that your app servers and services reside in. You need to ensure that you can adequately peer between all of these members, and especially as you distribute across more regions, which does add more networking complexity. So finally, let's go ahead and do a quick step into Atlas. And here, we're not going to take too long. I just kind of wanted to showcase what this process looks like. Now, again, everything I'd mentioned here can be done in a self-managed, community environment. These are all best practices, EA environment. But if you are deploying on or planning to deploy on Atlas, basically what you do is you go into the deploy new cluster wizard. You enable multi-cloud, multi-region option. And then here, let's pay attention to this as configured below option, right? So we can see here right now, we are deployed in a recommended region. So if you'll remember, I mentioned earlier, recommended region spans multiple availability zones. And we are protected, a 3-node replica set in US East 2 is protected against a partial region outage. So we know that this cluster by default is distributed across availability zones. But we want to step that up, right? That's not enough. We want a full region outage protection. And so let's go ahead and add in a couple more regions. And one thing to call out is as I increment these down, because I just basically want one node in each region. But as I do so, here you can see now I have an even number of nodes. 2 in West 1, 1 in US East 1, and 1 in East 2. Basically, it's saying, hey, here, we're not going to let you deploy this cluster because it does not conform with best practices. There are risks of split brain in this, and you should not do that. So anyway, we increment this back down, and we can now see that we are available during a full region outage, and we are distributed across 3 regions. If you'll remember, we talked a little bit about priority, assigning priority. Now in Atlas, we're not going to let you assign an arbitrary number, but we will allow you to kind of stack rank the different regions based on priority levels. So, if East 2 were to go down, then we would fail over to West 1. Whenever East 2 came back online, then we would re-elect that East 2 as primary. So we can continue to kind of iterate this, and if we wanted to expand to a 5-node cluster, as I mentioned, 221, And then, another thing to call out is the cloud provider option. So if we wanted to expand to different cloud providers, you can easily do so. And everything that I'm going through here can be done on pre-existing clusters. So maybe you've had a standard replica set, and over time your use case has grown, your user base has expanded to multiple regions, and you want to alter the configuration to be a multi-region cluster. You can absolutely do that, through the UI or through modifications via the API or Terraform, etc. And we'll do everything in a rolling fashion. So anyway, this is what it looks like once we have our desired configuration in place. We can go ahead and deploy. Again, we'll notice here that we are protected against a full region outage, but not necessarily a cloud provider outage because we're still across AWS. But that's it for this session. If you have any questions or would like me to elaborate on anything as a follow-up, definitely feel free to leave a comment below. And thanks for watching.